For most of human history, progress seemed slow and linear. Generations could pass with only modest improvements. But in the modern age, the rules have changed. Our tools, our machines, and our systems no longer advance step by step. They accelerate, doubling in power, shrinking in size, and expanding in reach. And that doubling doesn't just continue, it compounds. Let's put it simply. Exponential growth starts quietly, almost invisibly, and then explodes with astonishing force. Think of a lily pond where the number of lily pads doubles every day. For weeks, the pond looks mostly empty. Then, in just a few doublings, it fills completely, overwhelming the environment. That's the moment we're in with technology, on the cusp of sudden transformation. Take computing power as an example. In the early 1990s, a top supercomputer filled an entire room and cost millions of dollars. Today, a smartphone in your pocket outperforms that machine at a fraction of the price. And tomorrow, machines are set to outperform the human brain itself, not in centuries, but within decades. This shift is already visible. Computers now analyze medical images better than radiologists in certain cases. They navigate streets, land airplanes, make financial decisions, and even write code. Each success chips away at what we once believed to be uniquely human territory. And what's even more striking is how quickly these advances spread. But let's step back for a moment. What is it about human intelligence that has made it so powerful? Our brains operate with around 100 trillion connections, firing in parallel, allowing us to recognize patterns and adapt. Yet our biological brains are astonishingly slow compared to electronics. A neuron fires in milliseconds. A computer chip processes millions of signals in the same instant. This bottleneck means that while humans can be creative and insightful, we are limited in processing speed, memory, and endurance. Meanwhile, our inventions, our computers, networks, and algorithms don't tire. They scale infinitely, running nonstop at speeds our ancestors could never imagine. Here's where the real shift happens. Technology doesn't just grow, it builds on itself. Each generation of tools helps create the next. And unlike biological evolution, which took millions of years to get from simple cells to complex brains, technological evolution moves thousands, even millions of times faster. We've already witnessed dramatic examples. In 1997, IBM's Deep Blue defeated world chess champion Garry Kasparov, a moment many thought was still decades away. At the time, people said, well, chess is just calculation. Machines will never master intuition, creativity, or real-world skills. Fast forward, and today's artificial intelligence can compose symphonies, generate art, design molecules for medicine, and hold conversations that feel remarkably human. The truth is, intelligence is not a single mountain to climb, but a landscape of valleys and peaks. Once machines conquer one hill, chess, language, image recognition, they use that position to leap toward the next. Piece by piece, they are assembling the toolkit of human-level intelligence. And it's not just about raw power. Consider how quickly the pace of change itself is accelerating. The 20th century may have felt like an era of rapid invention: cars, airplanes, antibiotics, nuclear energy, computers. But according to models of accelerating growth, the progress of that entire century was equivalent to just 20 years at today's pace. By the middle of this century, we won't be talking about hundreds of years of progress. We'll be talking about thousands compressed into just a few decades. This acceleration is why so many predictions fall short. Experts often imagine the future based on the past 50 years as if the rate of progress will remain constant. But if technology is doubling in capability every few years, then 50 years from now, the world will be unrecognizable. This leads to a profound realization. The tools we are creating will soon rival the very organ that created them, the human brain. Within a few decades, machines are expected to match and surpass human intelligence in every domain. At that point, the distinction between our intelligence and theirs will blur. But what happens when machines become not just tools, but collaborators, partners in thought, creation, and even emotion? That's where we step into uncharted territory. The rise of superintelligence is not about replacing humans with machines, it's about merging the two. Already, we are seeing early steps: brain computer interfaces that allow paralyzed patients to control robotic arms with thought, or cochlear implants that restore hearing by uh, directly simulating neurons. These technologies don't replace us, they extend us. As these interfaces grow more powerful, the boundary between biological and non biological intelligence will dissolve. Imagine uploading your memories to a digital archive, linking your brain to the internet for instant knowledge, or running simulations of yourself to test decisions before making them. These are not distant dreams, they are natural outcomes of exponential progress. The transition won't be smooth or simple. Every new technology brings both opportunity and risk. Just as fire could cook food or burn homes, advanced AI and biotechnology will be both tools of creation and potential weapons. The choices we make now will shape how this transformation unfolds. But one thing is clear: we are approaching a point where the intelligence of machines will not just match ours, but expand far beyond it. By the end of this century, the non biological portion of our intelligence could be trillions of times more powerful than our brains alone. And when that happens, the story of humanity won't be about what separates us from our machines, it will be about how we evolve together. This is the rise of superintelligence, the moment when the spark of human invention ignites something far greater, and it's happening faster than most of us realize.